Hey there, space weather types. So we had a brief geomagnetic storm condition, and it was forecasted by this channel by a minor coronal mass ejection impact. But the real story is filaments. We'll tell you all about it here at the Smash News Network. Least busted name of news. Congratulations on realizing that the channel exists. This is the past 24 hours from SDO and ionized helium, and that filament there is a historically gigantic filament. We've been doing these space weather videos for well over 6 years, and that is the largest filament that we've ever covered on the channel. We've even added 193 angstroms ionized iron to that imagery to show some additional depth and contrast. That dark feature to the right of the Earth scale is what we're talking about here, folks. And those things have the capacity to become massive coronal mass ejections. We'll even show you the anchor points of that filament a little bit later in the video in different wavelengths here. It is anchored right between a couple of sunspots. We do have another massive plasma filament here setting on the northwestern limb. And we do have some more active regions rising in the northeastern limb, so plenty of stuff going on here today when it comes to space weather. Here's the equatorial view. You can see at least one new sunspot recently rose there, right near the equator on the eastern limb. Filaments, filaments, filaments are the story, though, folks. Again, those do have the capacity to become coronal mass ejections. Sometimes they release, sometimes they reposition themselves. Sometimes they just straight up collapse toward the chromosphere. So there is the southern hemisphere, and by the way, if you enjoy the content, the most comprehensive daily space weather content in the known universe, press the like button. Yeah, help the channel out. Press the like button. Press subscribe if you're new. Again, we've been doing the daily space weather content for well over 6 years, providing the most detailed solar imagery you'll find in the known universe, as well as the most comprehensive daily space weather, accurate forecasting. And yeah, I mean, hey, there's a market for it. It ain't going away. With the incoming popularity of private space flight, pretty soon you'll be able to book a vacation to space, folks. Won't you want to know the weather forecast for space? When you too can go there for under 6 figures, it's coming. It's less than a decade away. So press the like button, press share, press comment, press all the things. Thanks to everybody who has helped support the channel. If you haven't seen our shorts, go share those with your low attention span friends and foes. They might be able to gain some information about it, or perhaps just be in awe of the insane solar imagery that we show daily on the channel. There's always something going on in space. And here at the Smash News Network, Least Busted Name of News, we be covering it. We be covering it, y'all. Or something. If you want to support the channel, one of the ways you can do it would be to pick up merch. Check out our most popular merch. It's the Do Not Pole Vault the Caldera public service message merch. So if you're going on a volcanic vacation, leave that vault pole at home. Our finest days lie ahead. Civilization's not ending. Sorry, the universe is not being destroyed. It's not Armageddon, Apocalypse, Doomsday, Nibiru, Planet X, or anything like that. Things shall improve. If you're having a bad day, this too shall pass. So whatever you do, do not pole vault the caldera. It could be unhealthful, and we don't want our viewers to become a portion of the lithosphere. It features not only our homepage, but also the YouTube URL and an image of Steve Stimpak. Steve Stimpak, the world's leading volcanic pole vaulter. You can also support the channel by becoming a member of the Smash Team. Give Smash staff a raise by becoming a gold or silver Smash Team member. SmashOmash.com/Smash Team. We launched it back in October of 2021. The best value is the gold annual paid-up subscription. And we do send out email alerts, even to the bronze level. So, SmashOmash.com/Smash Team, kind of like Patreon, just way better, because it's our custom subscription services site. We are still on Patreon. Visit the homepage, visit the links, press like, press subscribe, press share. That's okay. We'll wait. Have you Have you pressed all of the things yet? Okay, thanks. So let's move on here to look at some SDO continuum imagery here. That's what's going on as far as sunspots, and they're looking mostly stable here in the past 24 hours. I don't see any major growth or degradation. But one new sunspot did rise in the east. So right here along the equator, there you go, there's a new sunspot just north of the equatorial portion of the closest star. And again, expect another sunspot to rise in the northeast here shortly. Let's take a look at what's going on. I ask you, let me ask you this. Did you know that Askja was inflating? Yeah, the Askja volcano, it was inflating. But now it has leveled off. So sorry, folks, I can't forecast a disaster there either. My bad. Askja volcano there, the deformation has ceased. Is it about to explode? Or is it just calming down? There's no indication that the magma rather has been receding. So anyway, that's the deformation map at Askja. There's a thermal map of Stromboli, which continues to erupt effusively as lava pours down the Fuoco, some kind of slope, I don't know. Stromboli's erupting, that's the point. Askja, I ask you this. Do you think it's going to erupt? Or maybe that magma will just cool down, who knows, but it's stopped inflating. So that tells us something. Abiko on Paramushir Islands producing a 11,000-foot plume of volcanic ash. Mount Mayon, unknown volcanic ash plume there over Luzon Island, Philippines. Mount Ibu exploding, flight level 070. It's a 7,000-foot ash plume over Halmahera. Luitolo exploding, flight level 070 there as well. Semeru producing a 15,000-foot ash plume over East Java. Another Indonesian isle. Dakono exploding, 8,000-foot ash plume over Halmahera from Dakono. It's at flight level 080. Headed down to Central America, Santiaguito. Another effusive, explosive eruption there, producing about an 11,000-foot plume of volcanic ash. It's a flight level 110 over Guatemala from Santiaguito. Sangay, flight level 210 over Ecuador. As Sangay and Revenador both explode. 16,000-foot ash plume from Revenador. 27,000-foot ash plume headed down to Peru there. Sabancaya exploding. Flight level 270. Unable to detect Ubanas. Not sure if we have a Peruvian eruption or not. Next, seismic activity. And we had 2 quakes over a 6 magnitude in the past 24 hours. So some significant seismic activity going on there. That's a 90-day bar graph for you. To give you a quick statistical look at a slight 7 magnitude earthquake drought. So we're seeing quite a few 6+ magnitude quakes here near Japan. However, the first 6 or greater magnitude quake that occurred over the past 24 hours was this one, a 6.4 south of Philippines. So that's a pretty big quake indeed. That one was at depth, though, over 120 kilometers estimated depth. Here's that quake south of Japan. That was a 6.1. That was right at the surface there. So, in any case, perhaps those 6 magnitude quakes at Japan are foreshocks. Remember, folks, any earthquake can be a foreshock. Anyway, we'll scroll up the list here and cite quakes of a 5 or greater magnitude. So there's a foreshock, a 5.2. Then we see a 5.0 at 11:13, only 8 minutes later. And then, only 8 minutes after that, a 6.4 at Philippines, way far to the southwest. Then, about 5 hours later, we see a 5.0 strike Iceland. That 5.0 was at 16:11 Universal Time. Then back to Japan with more quakes there. A 5.2 at 17:27, a 5.0 at 18:30, hardly an hour later. Then a 5.3 strikes Vanuatu. Major geologic unrest there in the Western Pacific. That 5.2 at Vanuatu was at 4:21 Universal Time this morning. Then Fiji had a 5.3 at extreme depth, over 500 kilometers estimated depth there. That was at, I'm sorry, that wasn't 4:22. That Vanuatu quake was actually at 21:01 Universal Time yesterday evening. The Fijian quake was at 22:22 Universal Time, and at extreme depth it was a 5.3. And then back to more shaken at south of Japan there. 5.4 at the Izu Islands at 23:18, a 5.1 at the Izu Islands at 23:47, a 5.2 at 1:05 this morning. Then Papua New Guinea sees a 5.4. So heavy earthquake activity there around the Western Pacific, continuing there. And then finally at 1:59 Universal Time this morning, a 6.1 strikes the Pacific Ocean there south of Japan, followed by a series of foreshocks, a 5.4, a 5.4, and a 5.7, and a 5.2. Indonesia had a 5.0 then at 4:25 this morning, 5.0 at Japan, 5.6 at Japan, 5.1 at Japan. So let's hope those 6 magnitude quakes are not foreshocks. And remember, folks, once again, let me reiterate, any earthquake can be a foreshock, even a large one. And let's return to space. Here we've added 171 angstroms to the 304 angstroms wavelength. That motion of the SDO, that's a calibration move to make sure that it is centered on the solar disk. And let's talk some stats. Oh, here's 171 angstroms first. There you go. The house favorite wavelength. We subtracted the ionized helium. Now it's just 171 by itself. And the 10.7 centimeter radio flux is now at 156 solar flux units, I believe it is. It comes from this area right here, just above the surface of the sun. That 10.7 centimeter radio flux is emitted by the upper chromosphere and lower corona. There's the 1-year graph. The radio flux there represented by the black line. The red line is the sunspot number. So a small uptick in the radio flux, and expect that to continue because we've got a sunspot rising in the east and another one rising in the northeast. Space Weather Enthusiast Dashboard didn't forecast any geomagnetic storms or geomagnetic unrest. However, we did. That's called accurate forecasting. We saw the coronal mass ejection. We timed the coronal mass ejection, and it was spot on. A minor geomagnetic storm ensued this morning exactly when we said, which was late on October 5th or early on October. Let me correct myself. Late on October 4th and or early on October 5th, which is exactly when it showed up. There it is on the graph. We'll show that in more detail here in a minute. First, let's take a look at Earth's magnetic moment from space for the past 4 hours. So there's what's going on in terms of magnetohydrodynamic pressure. That is the last 4 hours of Earth's magnetic moment, and that geomagnetic storm condition is subsiding. It's not a long-lasting coronal mass ejection. It was minor in the first place. Next, Earth's magnetic moment from the ground. And this would have sparked some aurorae. I almost went outside myself here in Pennsylvania, but I figured it's probably not worth it. Unlikely to really see very significant aurora from it. The timing was pretty good. But anyway, that's the last 4 hours of Earth's magnetic moment from the ground as this KP5 minor G1 geomagnetic storm subsides. So there's the KP index now back down to 2.33. It made it up to 5. The forecast was for it to not get above 6. So that's a pretty accurate forecast, wouldn't you say? I mean, we were saying that it was going to show up sometime around here, sometime between late day on October 4th and early on the 5th. Facts. We got them. I know, it's very controversial. Pardon the controversy, folks. I don't mean to be so controversial with all the facts. I know, it's just, geez, I'm terribly sorry about all the facts, folks. Terribly sorry. So here's the solar wind, and here's the CME impact. Let me just draw a box around that so that you're not confused. you might be confused by channels who cover space weather and have no idea what they are talking about. So anyway, there is the CME impact. You can see changes to the magnetic field, both in the field strength and vertical component. You can see changes in the solar wind speed and in the plasma temperature. Again, it was pretty minor. We only got to an 8 nanotesla field with a BZ of -7. Speed only made it up to about 460, nearly 470 kilometers per second before it finally subsided there. And now it is dropping back down promptly. So that little bit of warmer plasma there, represented by the green line there, that's the plasma temperature. And it looks like we are now in a much calmer regime. Looks like a new magnetic field here is coming through. So current conditions are about 5 protons per cubic centimeter. For the solar wind density, solar wind velocity about 440 kilometers per second. GOES magnetometers here had some minor perturbations there as that solar plasma showed up. You can see those little variations happening there around midnight local time for the GOES 16, which is this red M right here. The N's and M's represent noon and midnight local time for the geosynchronous near equatorial satellites. And let's move on to the top view ecliptic plane field plot. So things are pretty calm as far as sector boundary crossings as well. That is the heliospheric current sheet's polarity. And yeah, Earth is right in a South Pole current sheet here. No expectations of sudden changes there. Just keep in mind the magnetic environment can change with absolutely no warning. Continuing on to our line of sight field plot. There you go. There's the sun's B field in blue, photosphere magnetism in grayscale, polar fields in green for south and red for north. Which brings us to coronal holes. So there's the coronal hole scenario. We've got South Pole coronal holes except for in the southwest. So let's take a look at that from SDO's perspective. There is the 211 angstroms wavelength. So we've got some North Pole coronal holes setting down here. The rest of these are of South Pole orientation. That's the scenario. And we may see some enhanced solar wind from these systems up here. This system up here is looking more significant, and by the way, expect a continued uptick in coronal hole activity because, well, we've really seen a huge shortage of coronal holes throughout solar cycle 25. So these things are basically guaranteed to happen. It's just part of a solar cycle as the solar polar field reversal happens. And let's move on to sunspots. Sunspot number here did increase. You can expect it to increase again for the next day or two. It is now currently at about 170, maybe 171 there, according to the Royal Observatory of Belgium. Next, our flare monitor and scoreboard. And the most likely places for large flares are indeed yowzers. The most likely place for large flares are right in this triangle. And guess what? That huge filament is anchored right about here. So here's the filament is like this kind of, and that is a formula for a major coronal mass ejection. If it ejects at this point in time, it could very likely have significant earthly directed components. It's exciting times for the possibility of CMEs. So let's move on to look at sunspots here from SDO. There is the continuum plus 171 angstroms. Again, at least one new sunspot recently rose just north of the equator. Expect another one to rise farther to the north of that. Here we've subtracted 171 angstroms. And what do we have? Do we have any new sunspot groups? Any major changes? Not really. Those are mostly stable there for the past 24 hours. The time period depicted in this imagery. Next we'll move to solar energetic particles. Just a minor uptick there in the GOES proton flux. However, this is a situation where we could see a major uptick in the GOES proton flux because now we have a magnetic channel connecting the sun and Earth. So the possibility of a major proton event as well as major coronal mass ejections and indeed huge solar flares. So there was the possibility of an X flare yesterday with the motions that we were watching of that plasma filament. It has moved around quite a bit, but it is still largely intact. And again, it's still anchored right between three significant magnetically complex sunspot groups. So the possibility of major solar flares is actually very, very high. Period. Facts. And next to GOES X-ray flux. Largest flare was only this C3.76 right at 7 o'clock sharp this morning. And it's been underperforming, but there certainly is the capability for large flares. Let's take a look at the 94 angstroms wavelength. We'll zoom way on in on that. Again, the largest probability for M or X class flares is just south of the equator there in the western hemisphere. So this area right here, this triangle, that is the triangle of doom. The pink triangle of death. Seriously though, folks, if that filament ejected in its entirety and was directed directly at Earth, that could produce something like the Carrington event. So, we get comments constantly like, what would happen to Carrington event, Carrington event, Carrington event? We hear it constantly. And yeah, that is a kind of a scenario that could produce a Carrington event. It could also produce electromagnetic pulses depending on its magnetic orientation, like the vertical component of the magnetic field and the magnetic strength. There's a lot of different things that figure into what happens when a CME impacts. Are they likely to take down all of the grids of the planet and destroy all the satellites? Well, not really. So, but they could cause trillions of dollars of damage. Don't be surprised to see a large solar flare. We've said it many times. Solar flares don't cause coronal mass ejections. Coronal mass ejections cause solar flares. We think that plasma filament motions are what cause the solar flares to happen, not vice versa. They're happening at a very high rate of speed, so it's hard to say that A causes B or B causes A, but it's more physically plausible that the plasma motions are causing the flare, not that the flare is causing the plasma motions. Anyway, let's take a look at what's going on overhead over Lehigh Valley, Pennsylvania. It's still mostly dark here, but that is the scenario. You've got a lot of action up there. You've got Jupiter. You've got a gibbous waning moon. You've got Venus. And then you've got Mercury there. That's what's going on overhead here. That's our skyandtelescope.org star chart. Here is your solar system forecast, brought to you by the Smash News Network, Least Busted Name in News, and from theplanetstoday.com. This is where heavenly bodies are today. That is where heavenly bodies will be in 1 week. Heavenly bodies besides you, the viewer. Have you forgotten to press the like button? Oh my God. How dare you? Press the dislike button. Yeah. Pressing the dislike button is better than doing nothing. So press something. Leave a comment. Tell your friends and foes on Facebook about the most comprehensive daily space weather content and most detailed solar imagery in the known universe. Oh my God, what is going on there? It's a bird, it's a plane, it's a water tower, it's a UFO, it's the Pope's hat. Nope, it's the OSIRIS-REx sample capsule, which brought back some asteroid samples from the asteroid Bennu. So they're in the process of getting ready to open it. They haven't opened it yet. They're not opening it until the 11th. But they were in for some surprises in doing so, because there's a bunch of material from the asteroid even on the outside of the sample container. So exciting stuff. There is the ejection. There is the ejection of the sample capsule as OSIRIS-REx flew past dropped it off for the Utah desert, and continued on to the asteroid Apophis. Yeah, they found a bunch of dust. Dust that wasn't really inside the sample container, but must have remained intact after re-entry. So they ended up with more dust than they even expected. The question is it interstellar dust? Or is it dust from Bennu? I don't know. There's the touch-and-go sample collection process. It plopped down. It blew some air to blow a bunch of dirt inside of the sample container, and then it headed back off to planet Earth. Exciting stuff. I'm excited to see what's going on with the OSIRIS-REx capsule. I don't know if that's a cosmology story or not, but we do actually have a cosmology story to bring you after the astronomy photo of the day. There's the astronomy photo of the day. It's Monument Valley and an annular eclipse taking place over Monument Valley. Why? Because one's coming to Texas on October 14th. So don't miss that. Don't forget to hit up our Amazon shop at amazon.com/shop/smashomash and pick up some eclipse glasses so you too can go out and safely look directly at the sun. Or just look directly at the sun by using our channel. I guess that's not directly looking at the sun, is it? In any case, that's a lot more safe than looking directly at the sun. So pick up some eclipse glasses from the Amazon shop linked below this video. And on the homepage at smashomash.com. Here's today's cosmology story. And check it out. It's a bunch of novel shells. So some of these are planetary nebula. These are the remnants of stellar outbursts. So some of those could be considered supernoval. Some of them are just noval. The fact is, folks, novae are all big. So whether it's a supernova or just a major stellar outburst, novae are novae are novae. They're all big. Stars are big. You don't need silly terms like micronova. There was actually even a scientific paper published using the idiotic term micronova, a term that should only be used by people with micro penises. Just a ridiculous term. Stars are big. Novae are big. None of them are micro. It's an idiotic term. If Jupiter exploded like a star, it would not be micro in any way, even though Jupiter is way smaller than the sun. Anyway, what's the significance of all these novae? By the way, they're not organized like that. Somebody just put them in this spiral shape to look cool for the article. The purpose of the article, though, is to explain that most of these noval remnants are perpendicular to the galactic disk of the Milky Way galaxy. So you can read an article on that about, the headline is, Scientists discover source of mysterious alignment of stars near the galactic center. Ultimately, they don't know why they're aligned parallel to the galactic plane, but they are. I'm sure there's a reason for it. So, but in any case, it could just be a matter of orientation, but I sort of doubt it because, well, it wouldn't be a story otherwise. And anyway, that is an important aspect of cosmology, yes. Stars orient themselves with respect to their galaxy in various ways. And if you think the sun is oriented parallel to the galactic plane, well, it just isn't. Because, well, galaxies are very big and things are very far apart from each other. So, in any case, SciTech Daily has that article if you want to read about it. That's the cosmology segment of the day. Just a brief little blurb there about all of those crazy novel remnants. Again, some of those are planetary nebulae. Let us know why you think their tendency is to be parallel to the galactic disk. Continuing on to CMEs. And it looks like we have some anomalous data here on the George Mason University difference imagery there. You're going to see like a halo eruption, but there was no halo eruption, so I don't know what's up with that. It was just some kind of an error. Some kind of an erroneous halo showing up there. I don't know what's up with that. We don't anticipate there to be any coronal mass ejections that are earthly directed here. based on the data that we see. Anyway, that's 99 frames from yesterday. We'll let that play through one more time there. We were watching quite closely yesterday. I don't think there are any Earth-directed coronal mass ejections. Here are today's frames, an additional 43 frames from today. And part of that filament did eject yesterday. That's what you're seeing at the beginning there. As part of that massive filament reoriented itself, actually up near the polar region. We'll show you. First, some more coronagraphs. So we've got C2 as well as C3. We'll let those play through in their entirety, and then we'll show some closer imagery. So in the past 24 hours, I don't think there are any new Earth-directed CMEs. If you think I'm incorrect, let us know in the comments. We welcome all comments, and we read them all, even if we are unable to respond to them all. So keep in mind those are not synced. There's the latest from C2 and C3. Not earthly directed. We'll also show stereo A. And we show this because stereo A is represented by this red circle here. Here is the stereo A difference imagery and raw coronagraph on the left. Difference imagery on the right. So those are the latest CMEs. And let's move to plasma filaments. Dude, the filament scenario is berserk. Abso-smurfly berserk. Look at the filaments. Look at how many are in the southern hemisphere, how dense and large they are. I mean, it's a filament fest, folks. That's a triple F. A filament fest, folks. Massive number of filaments. And this one up here has gotten a name. Yeah, it's now called the John Katowski filament. So there it is, and it is still intact, folks. It might not look super clear in that imagery, but it is still certainly there in all of its glory. And by the way, if you want to name filaments after living people, your friends, your foes, or even yourself, join us over on Twitter. Just follow the hashtag #NameThatFilament. I know it seems easy to do, but it's apparently not easy to see people's content because of the censorship that continues on social media in a pathetic and criminally evil fashion. Free speech has not been fixed on Twitter. Censorship continues in a pathetic and ridiculous fashion. It is the scourge of mankind. It's the biggest problem facing humanity. In case you were wondering. X.com/smashomash. Follow the hashtag #NameThatFilament. So there's the filament. And look at that thing. It is berserk. I mean, here it is. That is a gigantic filament. Now, we're going to show the anchor point. It's anchored down here in between 3 sunspots. So, yeah, it is a scenario that could lead to some serious activity. So here we're going to show we've got 171 plus 193 angstroms here because just for a change to show some different frequencies there to show filaments. These frequencies do work well for that. And here's a zoom in of this setting filament in the northwest. So just some spectacular imagery there. 2 different species of ionized iron. And so you can get a feel for how big that other filament is, considering how zoomed in we are in this image via that Earth scale. So that's pretty sweet, right? Well, check this out. So there's where that filament is anchored, just to the left of the Earth scale there. And that's the southern portion of it. If that erupted right now, it would almost certainly have an earthly directed component. Again, it is between three significant magnetically complex sunspot groups, especially the one to its east. There's an even closer view of where that filament is anchored. And it looked like it was getting unstable around this area yesterday, but then it calmed back down again. So that is the part of the sun to watch. If you want to be the first to know about a massive coronal mass ejection, sort of in the what we would call the Earth strike zone. So that's what's going on. It is a filament fest, if ever we've seen one. And let's just cut back to where we started today, because check that out. It's time to get to our bonus feature segment. But first, the latest from the GOES 16 SUVi. Filament Fest. That's about the last 2.5 hours. There is the time and date stamp scenario. We will continue streaming it on Twitch. And let's blast through bonus features. Starting out with satellite charging hazards. We've got some minor ones here over the Eastern Pacific. That is when low energy electrons build up on the outside of spacecraft. Minor surface charging hazards there in the East Pacific. GOES electron flux dipped, as we forecasted, because of the CME impact, which we forecasted. There you go. There's the GOES electron flux. It'll probably come back up off the floor here in the coming 24 to 48 hours. Although there is another CME possibly on the way. So another one to arrive late in the day today, early in the day tomorrow. So facts. That could cause another dip in the GOES electron flux, which is essentially an erroneous reading, by the way, as it is a scintillation of the ionosphere, which is where the GOES 16 and GOES 18 measure the electron flux. There's the one-year graph of the relativistic electrons to contextualize that for you. And there is the NOAA forecast, which is almost exactly where we forecasted it to be. Why? Because of the CME impact. NOAA didn't forecast it because NOAA didn't forecast the CME impact. NASA didn't forecast the CME impact. Nobody forecasted the CME impact but this guy. So, facts. Pardon the controversial facts. You're welcome, astronauts, if you actually tune into the channel. Congratulations on realizing it exists. So here's the layer where it's measured, the F layer. See that red F? That's at about 300 kilometers of altitude. And there is what's shaken. And we will see some scintillation of the ionosphere because of a mild geomagnetic storm condition. That'll be accompanied by low-frequency anomalies. As denser material rises up, it doesn't want to vibrate as much. So low-frequency anomalies is what you'll see a little bit of. Not much, though, because it was a brief and mild geomagnetic storm. If that map is all Greek to you, the raw vibrational frequency, that's okay. Here's the anomalygram. And you'll see a little bit of red lighting up in this. That is the ionosphere getting excited. Again, that was quite minor. We could still see a little bit of motion in this in tomorrow's video, so don't be surprised to see that. Sometimes it takes a while for the plasma to make its way down to 300 kilometers of altitude, where the F layer is located. Because again, that geomagnetic storm just subsided. Anyway, there's the latest image, 11 o'clock Universal Time Ionogram and 11 o'clock Universal Time Anomalygram. We also showed total electron content and maximum usable frequency. So that is the Ionosphere Nowcast. And it's our newest feature on the Daily Space Weather videos. You can find it yourself if you like at the Space Weather Prediction Center. This is our transition from the ionosphere to the total electron contents. So that is your nowcast. Next, total electron content, which is free electrons from your GPS satellite down to ground level. That's about 12,500 miles of free electrons. And there is the total electron content forecast. Don't be surprised to see some anomalies in this. That is something that is typically accompanied by low electron contents, things like geomagnetic storms, coronal hole high-speed streams, and CME impacts. So a little bit of electrons have a tendency to get out of place, and indeed we do see that. We'll also show the anomaly for North America, and indeed we are seeing some high electron count anomalies there over North America. Also Central America, Northern Canada, the west coast of the U.S. I'll let that play through one more time before we close out our space weather video with the latest images of the closest star. And once again, thanks for stargazing with us. Once again, we apologize for all of the facts and accurate forecasts. So here is the scenario for the eastern limb. There's a new sunspot that just rose. Again, expect another one north of that to rise in the coming 12 to 36 hours. And there is the newest sunspot group to get named today. So that should add at least 6 new sunspots to the sunspot number. Besides that, things mostly stable for the past 24 hours. And let's move to meteorology. Before we do that, take a moment to support the channel. Remember I talked about the Amazon shop? Did you know that I became a pro cyclist in 1999 on the cross-country mountain bike? Yeah, if you want to know what supplements I take, well, you can find part of the list there at the Amazon shop, amazon.com/shop/smashomash. Zinc is on the list. I take mine at nighttime every other night along with magnesium. Don't take your magnesium with calcium, folks. Take your magnesium by itself separate from your calcium. They are co-antagonists. I take my zinc and my magnesium at nighttime. So get your zinc supplements perhaps through our Amazon store. Give Smash staff a raise that way. Give Smash staff a raise by ordering stuff through the Hemp Lucid shop, which, by the way, you get 15% off of your first order. Just enter your email address and pick up your CBDs, mushroom gummies, stress, immune, and sleep stacks through our Hemp Lucid shop. It's linked below the video. It's on the home page at smashomash.com. Our other paid affiliate / sponsor, smashomash.com. And welcome to the Neo Renaissance. Once again, congratulations on realizing the channel exists. Did you know that in 2018, a crack YouTube unit was sent to social media prison for a crime we didn't commit? We promptly escaped a maximum security social media stockade to the internet underground, where we survive as producers of fortune. If you have a problem, if no one else can help, and if you can find the content, maybe you can hire the Smash Team. No, you definitely can, because the link is right there. And if you're viewing this video, you can go to a website too, smashomash.com/Smash Team. Email alerts, additional content, especially for gold level Smash Team members. You want to learn about my crap theory, the only plausible known theory that explains the mechanism underlying the solar sunspot cycles? Then become a gold member of the Smash Team. Otherwise, you can't get it because it's not published yet. It's not submitted for peer review yet, but gold Smash Team members get it at smashomash.com/Smash Team. Let's talk about the world's largest waves. I think they're just south of Taiwan here right now, but we're going to take a look. So we're doing a wave chase here. This depicts wind speeds and significant wave height as we transition to our meteorology segment. So those are the world's largest waves, I think, although the Southern Ocean has some honorable mentions as well. Some decent waves over there. Some decent waves over here. Yep. South of Taiwan. Those are the world's largest waves. So surf's up, Taiwan. You've got some, oh, looks like it's been subsiding for the past couple of hours. It was over 30 feet. Yeah, we got some 30-footers in there. So the seas are pretty calm here at the moment. The least calm portion is right there. Let's move to regular meteorology. There are the surface winds of the eastern world. Shout out to our viewers from this side of the planet. There are the jet streams like sands through the hourglass of time. Those are the jet streams of your lives. These are the jet streams of the central world. That's Europe, Africa, and the Middle East. There are the surface winds. And like sands through the hourglass of time, these are the surface winds of our lives. For the west. And there is the jet stream scenario. Check it out. Upper level high over southern Mexico there. You see that? That is a clockwise rotation known as an anticyclone, accompanied by clear skies and high pressure. Why? Because atmospheric nitrogen is more massive than atmospheric water. That is why clear days have higher pressure than rainy days. Yeah, nitrogen, it's more massive than water. It's just a basic fact of atmospheric physics. Speaking of physics, check this out. 39 nautical mile long iceberg grazes Clarence Island. This thing's been floating around for 2 years. D-30A. An absolutely massive iceberg. And fortunately, it got out of the way of the penguins, because there were some chinstrap penguins there that were not disrupted by that thing. It kind of just brushed by Clarence Island because Clarence Island has an extremely steep shoreline. Yep, that's Antarctica, by the way. Figured I'd share. Anyway, since temperature is always in the news, and we don't really say the word climate here very often. I don't really do climate, but there's temperature. Man, oh man, it's looking a little bit chilly in Denver. What's going on? Is the hot air subsiding? There's so much hot air coming out of Colorado constantly. Geez. I mean, I guess it's not hot enough to cool that down. It's looking a little chilly there. 22 degrees. 23 degrees at Crested Butte right now. There's your temperature map for the U.S. Next, clouds and fog. Clouds and fog depicted by the shortwave radiation map. There you go. That's what's going on over the Americas. Yes, shortwave radiation satellite. If you think the Earth is flat, please explain why this looks like a sphere. I'll tell you why it looks like a sphere, because NASA has taken the croissant-shaped Earth and photoshopped it into a fake sphere. Next, our weather.gov map, and we've got a bunch of, those are freeze warnings or frost advisories or something like that. Those are freeze watches there over the north-central U.S., some flooding around the southern U.S. Weather.gov is where to get your weather warnings. Those are too many counties to cover, so let's cover some forecasts. There's a 72-hour GFS pressure and precipitation forecast. Seeing some heavy metal weather there, about to make a sudden turn to the south at Texas. Here is our total accumulated precipitation forecast in inches based on the same GFS 72-hour model. Ta-da! Next, the temperature anomaly forecast in degrees Celsius based on a GFS 72-hour model. We show 72-hour models. Why? Anybody? Anybody? Leave us a comment and let us know why. It's because they're accurate. Yeah, we can forecast the weather about 3 days out. About 4 days out? Not so much. 50 years out? What do you think? Cold weather coming to the east as we forecasted like a week out. Why? Because if you understand atmospheric physics, you can forecast a little longer out. I don't know. Too controversial for you? Geez, I'm terribly, terribly sorry, folks. Sorry for all the controversy. Here's our lightning mapper for the past about 10 hours, and Texas has been the lightning capital of the U.S. We do have some strong storms continuing there, I think. Here's our real-time lightning map from lightningmaps.org. And it looks like Austin has got some thunder rolling in. Faux show. Faux show. You want to forecast thunder? Lightningmaps.org. You want to pretend you're a horror movie villain? You want to frighten the natives and pretend that you're Zeus or Thor or something? Lightningmaps.org. Powered by blitzautung.org. And there's another cell out there to the west. Here's your full globe lightning map. Lightningmaps.org is now counting nearly over 600 lightning strikes per minute at the moment. Here are those storms. And the jet stream is about to get involved here. In fact, it's already involved. It's going like this. It's already cold in Dallas, folks. I can tell just by looking at that map. That is a matter of understanding atmospheric physics. So you too can forecast your weather, which is what we empower our viewers to do. Some heavy precipitation there at Alaska. We empower our viewers to understand science and to be able to forecast for themselves. So we'll close out the video with U.S. Doppler radar. For the lower 48. So there's U.S. Doppler as that cold air pushes that moisture through. Or you can see that cold air dipping down there, making its way into Missouri as we speak. And there's the water vapor map. That should clear things up. There's a compression happening right now. This dry mass of air is having a collision with this relative low. Cold air pushing down like this. Dry mass of air right here. That is a recipe for that strong line of storms. Anyway, there's your recap. U.S. Doppler radar. Clouds and fog. And water vapor, as in all of it. Next, this is me signing off and thanking you for tuning in, congratulating you on realizing that the channel exists, and wishing you the best. I'm headed back to the bunker because I'm spooked of space, pardon the sarcasm, and while I'm gone, may that solar wind be at your back.